Hello, and welcome to Learning Outcome 5. Being able to create a software program to solve a problem using object-oriented programming. In today's session, we will explore the question, how can object-oriented programming be used to solve real-world problems? This video demonstrates the development of a course enrollment system using LO5 principles, showcasing how structured design, modularity, and reusability contribute to effective and efficient software solutions. UK Versity requires a system to manage student enrollments and assessments. The system should allow staff to register students, create courses with capacity limits, and record marks. Data integrity is key, ensuring no duplicate IDs and valid marks. The software must generate reports, such as transcripts and course rosters. This problem is ideal for an object-oriented solution. Functional requirements include adding and removing students and courses. The system must enroll students with capacity checks and record marks accurately. Non-functional needs focus on a simple UI and data persistence. The software should be extendable for future features like attendance tracking. All data must be stored in a JSON format for easy access. The design includes classes for student, course, enrollment, and registrar. Each class has specific responsibilities, promoting encapsulation and cohesion. Relationships are defined, like a course having multiple enrollments. The registrar acts as a facade, managing operations and data persistence. This design ensures low coupling and high cohesion. A flowchart illustrates the system's operations, showing data input and output. Algorithms handle enrollment, mark recording, and report generation. Decisions enforce data integrity, like checking for duplicate enrollments. Processes map directly to class methods, ensuring clear logic flow. This structured approach aids in debugging and maintenance. The system is implemented using Python, a language supporting LO5 principles. Python's simplicity and portability make it ideal for this project. The code is modular, with clear class definitions and methods. Debugging tools like breakpoints and print statements aid development. The program demonstrates OOP's power in solving complex problems. Unit tests ensure each class and method functions correctly. Testing checks enrollment capacity, mark validation, and data persistence. Automated tests confirm the system meets requirements. Error handling is robust, providing clear messages for invalid inputs. This thorough testing guarantees reliability and accuracy. The system is deployed as a standalone Python application. Installation involves setting up Python and copying necessary files. The application runs with simple commands, saving data locally. IDEs like VS Code aid in debugging and maintenance. This deployment ensures easy access and operation for staff. The user requirements document outlines the system's purpose and scope. It details functional and non-functional requirements for clarity. The document defines roles, responsibilities, and access levels. Constraints and assumptions guide the development process. This document serves as a blueprint for the software solution. The development plan follows an agile-inspired iterative approach. Phases include analysis, design, implementation, testing, and deployment. Each phase has specific deliverables, from URD to final system. The plan ensures a structured, controlled development process. This approach allows for early testing and continuous improvement. The system design is based on an object-oriented model. Key classes include student, course, enrollment, and registrar. Relationships and responsibilities are clearly defined. A UML class diagram illustrates the system structure. This design ensures maintainability and scalability for future enhancements. The testing strategy includes unit, integration, and system testing. Tests validate requirements, ensuring all functions operate correctly. Validation rules trigger appropriate error messages. User acceptance testing confirms the system meets user expectations. This strategy ensures a reliable and robust software solution. Potential risks include data corruption and incorrect validation. Mitigation strategies involve atomic save/load and extensive testing. User errors are addressed with clear error messages. Late design changes are managed through modular design. This assessment ensures risks are minimized and controlled. The system meets all business and user requirements. Improvements could include a graphical interface and multi-user support. Migration to a database would enhance data handling. Future enhancements may involve additional reporting features. Continuous evaluation ensures the system remains effective and relevant. The system performs all key functions as expected. Enrollment, mark recording, and reporting are accurate and efficient. Data persistence is reliable, ensuring no loss of information. The software is user-friendly, with clear prompts and messages. This evaluation confirms the system's functionality and usability. The system executes operations within 1 to 2 seconds. Memory usage is efficient for expected data sizes. JSON format ensures reliable data storage and retrieval. No crashes were encountered during testing. This performance evaluation highlights the system's stability and efficiency. The system's UOP design supports easy maintenance and updates. Modular components allow for seamless integration of new features. The code adheres to PEP 8 standards, ensuring readability. Future developments can be implemented without rewriting existing logic. This maintainability ensures long-term system viability. Validation prevents duplicates and invalid entries. Data is safely stored and retrieved without corruption. Error handling ensures graceful recovery from invalid inputs. Testing confirms reliability across multiple scenarios. This reliability and integrity are crucial for user trust and system success. The software is console-based, requiring command input. Future work could include a graphical interface for ease of use. Multi-user support and database integration are potential improvements. Basic reporting could be enhanced with export options. Addressing these limitations will further enhance system functionality. The system is fully functional, meeting all major requirements. It is easy to use, with excellent performance and maintainability. Data accuracy is verified, ensuring reliable operation. Security features are basic, with potential for future enhancement. Overall, the system is a robust and effective solution. In conclusion, the course enrollment and assessment system effectively addresses the challenges of manual enrollment and assessment tracking. It fulfills all functional and business requirements, ensuring both reliability and usability. This project clearly demonstrates the power of object-oriented programming in developing structured, efficient, and scalable software solutions. Thank you for watching this video. If you have any questions, please feel free to send a message via WhatsApp at 07,484,361,688. Thank you for your attention and see you soon.